Section 2.5, Solving Compound Inequalities, Part 2, AND Problems. Let's revisit the party that Mr. Callan was going to throw. If you remember from last time, Mr. Callan was going to throw a party, and you were going to be invited if you've ever been named Super Bowl MVP or if your name was Tom. Well, when he made out the invitations, he made a slight mistake, and instead of writing the word or, he used the word and. And so all of these people that we had considered before, all of these Super Bowl MVPs, all of these people named Tom that were invited now aren't going to be invited. Sorry, Dexter Jackson, you're not named Tom. Same goes for you, Troy Aikman, and you too, Deion Branch. Oh, we get some Toms over here, but I'm sorry, Mr. Meade, you've never won the Super Bowl, let alone be named MVP. Same for you, Tom Hanks. Same for you, Tom Cruise. Getting into this party would be a mission impossible. The good news is we still have one person invited to the party, and that's the only man to be named Super Bowl MVP and be named Tom, Mr. Tom Brady himself. With this problem here, we see that by saying and instead of or, we actually often limit what we're talking about. We need to satisfy the two conditions of being Super Bowl MVP and being named Tom. That's why we look in the middle of the Venn diagram. All right. Now let's take a look at this with some algebra. Inequalities that are combined by the word and are also called intersections, like the intersection of the Venn diagram, the middle, or they're sometimes called conjunctions. Occasionally we'll use a symbol that looks like an upside down U instead of the word and. That's similar, it's upside down compared to the symbol used for an or problem, also known as a union or a disjunction. The steps for this are very similar to the steps for solving an OR problem. The first two are actually exactly the same. First, we're going to solve each inequality separately. Then we're going to graph each solution on the same number line. Now, when we do that, we're going to finalize our answer by looking at the part of the graph that's covered by all of the arrows. Typically, we're only going to work with two, but this would work if we had multiple inequalities exceeding just two. So let's start by solving each of these inequalities here, and then we'll worry about the graph after. So go ahead and solve each inequality. Alright, so when we solve each of these, we get x is greater than -1 and x is less than or equal to 3. Now that we've done this, we're going to put them on the same number line. So I'm going to position my -1 and my 3, an open circle at -1, a closed circle at 3, and go to the left. Okay, so let's fix that arrow up just a little bit there. Okay, so there we have our two graphs. We now want to finalize our answer on a good number line, our final answer here, by looking at the part of the graph that's covered by all of our arrows. And again, in this case, we just have two. Well, if we look at -1 and 3 as two different breaks in our number line, we have all the numbers to the left here, which are covered by this one arrow. Everything from 3 to the right is covered by just this arrow, but everything in between is covered by these two arrows. And this is the most typical situation you'll have with an AND problem. We want to look at everything that's covered twice, and that's between -1 and 3. So what we do is we're going to fill in the circle at 3, leave the circle open at -1, and just connect them. Form this little bridge. That right there is talking about the same interval up here that had both arrows from -1 to 3. So this is going to be the final answer that we want graphically. That's a typical AND problem that we have. When we do that, some ways we may see our answer rewritten from right up here. We can actually kind of rewrite that where we start with the smaller number, -1. We say that that's less than x, and that x is less than or equal to 3. These are both identical. Either one would be acceptable. You could put it either way. But if you do it this way, you have to make sure that both of the inequalities are kind of facing the same direction. And remember that this means that x is bigger than -1. -1 is less than x, and that's the same thing that we're saying here. And x is less than or equal to 3 is the same thing that we're saying here. And so there you go. That's how you would do it. This is your graph. either of these would be your final answer. All right, let's try some more practice. Just like with an OR problem, sometimes the graphs can be a little bit tricky. So we're going to continue to look for the overlapping section of the arrows. We're going to start with our example on the left. 3y plus 5 is greater than or equal to 2y plus 1, which is greater than y plus 1. Now, in this case, it looks like we have one thing. We're not really sure how to handle it. What we do is we're going to split it up into two different inequalities. The first inequality, I'm going to take everything up to, but not including the second inequality symbol. And I'm going to write that down first. And so you can see that I've gone all the way from 3y plus 5 is greater than or equal to, all the way to the end of 2y plus 1. Now the second inequality is going to start with that 2y plus 1 and finish off the combined inequality. So I'm going to write that one down. And so the 2y plus 1 has to be used with both in its entirety. A common mistake is to just use 2y over here and just use 1 over here. Don't make that mistake. All right, so now go ahead and solve each of these two inequalities. Come back and check your work. Okay, so when we solve this, we get y is greater than or equal to negative 4 for our first inequality, y is greater than negative 2 for our second inequality, and we do have to make sure we combine these with a particular word, and this is going to be an AND problem. Anytime that you have an inequality like this, where you have two inequalities kind of right next to each other, it's an AND problem. One way I remember that is it looks like I have two things on the outside and something in the middle. Kind of reminds me of a sandwich, and the second, third, and fourth letters of sandwich are A and D. So I think of this as a sandwich problem, and that's how I know it's going to be an AND. Now I want to graph this. So I'm going to graph this on the same number line. I've got negative 4. I have negative 2. Open circle it, negative 2 to the right. Close circle it, negative 4 to the right. So this doesn't look like the typical AND, where they go towards each other and form a little bridge. They're going in the same direction here. And so what I really need to do is look for the overlapping sections. So where these two arrows overlap is to the right of negative 2. And so that's actually what I want to include for my final answer. I want to go to negative 2, put an open circle, and go to the right. And that's the only thing that I want to include for my final graph. I can't include the area between negative 4 and negative 2 because that only satisfies one of my conditions. It doesn't satisfy both. It doesn't make this inequality true. It only makes the first one true. And so that's where I'd want to have that. And if I really wanted to write out just the true final answer algebraically, it actually would just be y is greater than negative 2. I don't want to include the greater than or equal to negative 4 because this is the one section where they overlap. All right, same type of thing on the second problem. Go ahead and solve each one and then put it on the number line initially, and we'll see what we can do with it. Okay, so we see that when we solve these inequalities, we get n is greater than 1/5 and n is less than negative 1/2. When I graph that, I end up having this number line here, which looks like a typical OR problem as opposed to the AND that I expected. Well, I have to still look for the overlapping section. Where do these arrows overlap? They don't. They don't overlap at all. So since there's no place that they overlap, this is a special case here where I'm actually going to have no solution. If I wanted to do this graphically, I could show this on a number line without any arrow above it, and that just would show that there's no solution. Or I could use the empty set notation to show that as well. So any of these three ways are all saying that there's no answer that works here. All right, so that's it. Whenever you have an AND problem, just graph them after solving them and see where the arrows overlap. If there's no overlap, then there's no solution. All right, time for you to get some trials in. All right, so let's take a look at the first one here. You'll notice I'm using the intersection notation there, but it just means AND. Go ahead and solve that first one and graph it, and then graph your final number line as well. All right, see how you did. Alright, so you can see your final answer here is x is greater than -1 and x is less than 8. Of course, the alternative to writing that would be -1 is less than x, which is less than 8. Those being the same thing. And then here's your graph. -1 to 8, the arrows go towards each other, and so the overlap is the bridge in the middle. Alright, move on to the next one. Make sure you split it up into the two inequalities first. Let's see how you did. Alright, so when you do this problem here, you get 15 is less than d, or d is greater than 15, and d is less than or equal to 9. When you do the graph of that, you'll see that they go away from each other, and there's no overlap. So the solution that you'd be looking for is actually all real numbers with an empty graph. There'd be nothing on it. Alright, let's get two more problems in. Alright, let's try each of these problems. Go ahead and solve and then graph the first one. We'll take a look. Alright, when you solve this one, you get k is less than -2 and k is less than 2. You do the graph, you see it's one of our special cases where they're both heading in the same direction. Where's the overlap? The overlap is over here. This is where the two arrows are. So that's everything to the left of -2. So we can just say k is less than -2, and that would satisfy it. And then we have our graph. Open circle at -2, arrow to the left. Alright, one last problem. Split it up, solve each inequality, and graph. How'd you do? Alright, and then you can see for this last one that when you solve it, you get x is greater than or equal to -1, and x is less than 5. So the greater than or equal to, I guess I actually have to fill in the circles here at -1. Don't want to forget that. Always good to double check. And when I draw them on the same graph, you see they go towards each other, which is a typical and. And when that happens, I also can just look at the connection between them and go from -1 to 5. So there you have it. That's how you solve combined inequalities that involve the word and. And now you can solve them using and, or. Hope this makes a lot of sense and that you feel confident going into the problems that we'll look at in class.